Good evening, everyone, and a very warm welcome to Codemania version 6.0, Workshop 1 on Data Preprocessing and Augmentation, an online session organized by the IEEE Computer Society Eastern Branch chapter of SLTC. It's wonderful to see participants joining us from different academic and professional backgrounds, all connected by a common interest in data-driven technologies. In today's workshop, we will explore an important part of data science, how raw and unorganized data is cleaned, processed, and turned into the useful information. We truly appreciate your time and consideration, and we are excited to take you through an insightful and practical learning experience. So, without further ado, let us officially begin. To formally welcome our honorable guest speaker, special guest, and all participants, now I would like to invite the project co-chairperson of Codemania version 6.0, Ravishkar Ratnayaka, to deliver the welcome address. Ravishkar, the virtual stage is yours.
Thank you, Naveen. Good evening, everyone. I'm Ravishkar Ratnayaka, co-chairperson of Codemania version 6.0. It's my great pleasure to warmly welcome you all to Workshop 1, Data Preprocessing and Augmentation, organized by the IEEE Computer Society, Eastern Branch chapter of SLTC. Codemania version 6.0 is more than just a competition. It's a learning journey designed to strengthen analytical thinking, problem-solving skills, and technical confidence among undergraduates preparing for today's fast-evolving tech industry. This workshop marks a beginning of the journey. Understanding how to prepare and enhance the data is a crucial foundation for building accurate, reliable, and scalable machine learning solutions. We are truly honored to have with us today Mr. Indira Veerasinghe, data scientist at John Keel's Octave, as our guest speaker. So thank you for your taking time to share your valuable industry knowledge and experience with us. I would also like to extend our sincere gratitude to Dr. Sanika Vijayasekara, Dean of the Faculty of Computing and IT, Dr. Lasit Jasaketu, Branch Councillor and Senior Academic Treasurer of the IEEE Eastern Branch of SLTC, Ms. Varunika Hibbola, Branch Academic Advisor of IEEE Eastern Branch of SLTC, and Engineer Chamira De Silva, Head of the Department of Data Science. Your continuous guidance and support make initiatives like Codemania possible. I would also like to extend a warm welcome to Mr. Dharanjay Atigammana and the advisory panel, Ms. Netmi Fernando and the roundtable members, and the IEEE Computer Society Eastern Branch chapter of SLTC, including Ms. Vimarshana Kitmini, the Executive Committee, Organizing Committee, and Media team. We are truly delighted to have all you here with us today evening. To all participants, stay curious, ask questions, and full engage in today's session. The knowledge you gain here will be a strong foundation for your Codemania journey and your future careers. Once again, welcome to Workshop 1 of Codemania version 6.0. I wish you all a productive and insightful session. Thank you.
Thank you very much, Ravishkar, for setting the tone of today's session. It's now my great pleasure to introduce our speaker for this evening. We are honored to welcome Mr. Indira Veerasinghe, data scientist at John Keel's Octave. Mr. Veerasinghe brings extensive industry experience in data analytics, machine learning, and real-world data engineering workflows. His hands-on exposure to enterprise-scale data problems makes him exceptionally well-positioned to guide us through the practical and strategic aspect of data preprocessing and augmentation. So, without further ado, I warmly invite Mr. Indira Veerasinghe to begin the session.
Thank you everyone for the introduction. So, good evening everyone. So, can you hear me properly? Hello. Can someone confirm on that? Can you hear me? Yes. Okay, so as the organization committee introduced about me, so I'm working as a data scientist at Octave. So I did my bachelor's University of Colombo. Now I'm following my master's in University of Moratuwa, right? So with the experience I have, I just going to brief you about the data pre-processing and the data augmentation, how that we are using that, what are the techniques we are using in the industry and all. So we'll move to the presentation. Hope you can see my screen, right? You can see the screen, right? Yes, okay. So today we are going to talk about the data pre-processing and the augmentation, right? So this is in the when we so before move to the data augmentation and the pre-processing, we'll see why we need the data pre-processing. What's the need of this, right? So I know the most of you are working with the machine learning, building some fancy models and all. So why we need the pre-processing and the augmentation, right? It's one of the question you have. Why we need why this session we need this session, right? So think about so if you have a good data, right, the whatever the quality data, then your model is more accurate compared to the if you have unclean data, right? So industry, when we talk about the industry, 80% of the time is a pre-processing, right? So the only your 20% is your model. As example, so when we talked about the machine learning, that the data science process, right? The most of the time we are allocate to the data pre-processing and the data augmentation, right? So, so when we talk about some of the real world scenarios, right? If you are using the same model with the whatever the you can create some of the features and you can do whatever the different pre-processing approaches you can use. Think about you have the bad pre-processing, right? Then you are whatever your final model is, you are getting a poor accuracy, right? But if you use the same whatever the simple model, right, with the clean data, then your model is giving high accuracy, there's no overfit with the model, right? So and then your model is whatever the it's satisfied with the whatever the business requirement as well, right? So this is some of the Kaggle winners, they are from their they are saying they are spending more hours for the feature engineering and documentation, not deciding some of the fancy models, right? So now you have a good understanding about why we need to learn this data pre-processing and documentation. It's cover up your 80%. The mostly we have to put 80% of your time to when we are working with the data science approaches, right? So with that knowledge, right, we'll see in the data mining and the data science process where we have to do. So it's like the data mining and data science, it's like a process, right? Under this process where we need to use this data preparation, data processing and the augmentation. So we'll talk about the first step, right, in the data mining in the process. The first one is the business understanding, right? Business understanding means, so sometimes the business come up with some of the pain point. It means some of the problem they have, right? They want an analytical solution to come up with the to to come up with a solution for that. Sometimes we will identify there's a it's a pain point for the business, it's a challenge, or they it's a challenge for the business, then we'll identify that requirement and we'll suggest an analytical solution. Okay, this is a already this kind of problem you have, right? So we can create a solution using the analytics, right? So there are two ways the requirement can come. The first one is directly from the business side, and from as a data scientist, as a data analysis perspective, we can suggest this is a pain point for you, then we can suggest a solution using the analytics, right? The first thing is, think about you have a business problem, right? Now we are trying to solve that with the analytics, advanced analytics, right? So first you need to understand the problem clearly. What if you have any doubts and any unclear points regarding the requirement, you need to clarify with the business. You can say take some of the meetings and all, then you can clarify business. Then you need to have a proper 100% understanding about your business problem. Otherwise, if we are not understanding the problem, how we solve the problem using the analytics, right? The first step is to understand the problem, right? Then the second one is, so to solve, if it is a modeling part or it is a, sometimes we can go with the, without going the modeling, we can use some of the rule based approaches. But to solve it using the analytics, we need to have a data, right? So the second step in this process is to understand the data. How understand the data means what sort of a data they have, right? So according to the domain, there are different data sets, right? So the second step is to understand whatever the available data, right? So the third one is the data preparation, that pre-processing parts coming. And so so you need to, if there is any missing values, or else you can create some of the new features, right? According to that, you have to do some pre-processing and the augmentation in this stage, right? So think about, now you have the whatever the clean data with the whatever the granularity according to your uh, according to your business problem. You have the whatever the data with the correct granularity, right? Then you can using the whatever the fancy models and all, you can create, you can train your model, you can evaluate. Then after you train your model, you can evaluate your model, right? Then think about, now you have the final model with the good accuracy, right? Now you need to deploy it. It means you need to productionalize. If that, as example, the business have a problem using the analytic, you developed whatever the model, right? If it is reduced whatever, sometimes we can't reduce that problem into 100%, but if can, if that problem covers 80%, 70%, right? Then if the business is okay with that, if they, from this model, from this output, if they generate any value, right? So then with the business confirmation, is the solution is enough, is that whatever the solution we built, is that enough for them, then we can deploy, or we can productionalize our final model, right? This is a simple data mining or the data science process, right? How we deal with. Under that, under the data preparation and the data understanding part also, we can do the data processing, pre-processing, and the data augmentation. Now you have a good understanding, but under the data mining, data science process, in which section we are using this data pre-processing and the data augmentation, right? So we'll talk about the today's content, right? Now you have idea about why we need this session, and where under the as a data scientist in their day-to-day life, where we are, in which point we are using this data pre-processing and the augmentation. With that knowledge, so in the today's content, I'm going to talk about, so understand the raw data, how you understand your raw data. In the pre-processing, how you, if there is any missing values, how you handle, what are the techniques you can use. If there is any outliers you identify in your day, whatever the columns and the features, right? How to handle them, right? And the how you scale and the transformation your data. If there is any categorical variable, how you encode that to the numerical, right? So what are the some of the pre-engineering techniques? And the finally, we are talking about the data augmentation, right? So then we'll jump into the understanding the raw data, right? So think about, so when you are working in the industry, right? You have to deal with couple of data sets, just not only the one data set. There can be multiple data sets. So think about, you got a business requirement, you clearly understood the whatever the requirement. Then now you are going to the next stage, the understanding the whatever the available data, right? It's a must, because if you don't have any, if you are not understanding your features, then how you do the pre-processing, right? So for the you need to have proper understanding about your raw data, right? So first thing is, if you have any sort of a table in the, think about it's in the tabular format, right? So what does one row represent, whatever the single row means. So in this example you can see what this simple row it means. It is the customer, is it a particular customer or a whatever the employee, right? You need to got to understand what that simple one row means. And so you need to know about the target linkage. So in this data set, so in the later part we are talking about the uh, train and test split, right? So in that part you need to avoid, when you are training your model, right? You need to avoid to add the whatever the future data to the training data set, right? We'll talk about that later. That simply means you need to avoid to adding the whatever the future data to the your training data set, right? So then you need to have a good understanding about, think about, if you have two or three tables, right? You need to have a good understanding about what is the granularity of each table, right? So think about think about some of the times to create the whatever the final data sets, right? You need to have a, in the industry we are saying it for the master data frame, right? We need to create a master data. To create that master data frame, you need to do couple of joins with the your whatever the available data set. To do the joins, you need to have a good understanding about your what is the granularity of this table, right? What is the, how we identify the whatever the unique row, right? Simply our primary keys, right? So you need to have that understanding, right? And if there are any features, is that related to the time, right? What is the dependency, right? You need to have that understand, right? Then some of the features, like, so if you are working in a domain, there are some domain specific words, right? You need to just, for that domain specific names can become as your feature for your whatever the model building, right? You need to sort of understanding about what that word means, what that in as example. So in here you can see the policy type, right, in this table, right? What this policy type means, what are the different types of categories can be had, right? Sort of, if there is any business term, business related word, the domain related word, you need to have that understanding. You can directly ask that from the business and you can get the whatever the meaning of that particular word. But you need to have that, I'm just saying, you need to have that, the knowledge, the business, if it is a business related feature, you need to know that what that business term means, right? So these are the some of the if you have a data set, these are some of the things you need to know before move to the pre-processing part, right? Then we'll talk about, think about, now you have a good understanding about your data set. Now you know the each feature. Now you know the what is the granularity, right? The whatever the time dependency features, and you clarified with the business about the whatever the business related words. Now we are starting your pre-processing part, right? So in the firstly, we are going to talk about how we handle the missing values, right? If you have any missing values in your data set, how we handle. Before going to that, what this missing value means, right? So we are saying it's a placeholder for the data that is unavailable. It's not, there's no recorded here, not applicable. Oh no, it's not applicable, right? So if it is not applicable or the unavailable, right? Why it matters for us? That there's, as example, think about in the previous example, right? In this table, think about the policy type. Some of the types is not whatever not applicable in the data set, right? So we are saying that as it's a missing value for that particular column, right? Then if it is not applicable, it's unavailable, why it's matter for us? Why we need, as a data scientist, why I need that, right? So the one thing is, if you have that whatever the missing data, right? So it can lead to inaccurate analysis, right? Sort of a thing. Just think about for a for the one of the categorical variable, right? Think about the the 20-30% of you have the missing values. Then you are simply you have the null values, right? Without knowing that, you are saying, okay, whatever the with the customer data set, my 80% of the, think about this policy type column, right? So in here you can see we have the basic and the premium, right? But it's 20% of them are null, right? But you are saying, without knowing that, without handling that, you are saying, okay, my 50% is from the basics and the premium 50, the other 50% from the premium. It's true because you have 20% nulls, right? You can't directly come up with that conclusion, right? You need to have a way to how I handle my null values. After handle that, you can come to your whatever your final conclusion, right? So if we didn't handle that, it can be lead to the inaccurate analysis, right? And you have to, it affects your whatever the when you are doing the training and the whatever the evaluation, right? We'll talk about some of the models. They can simply from the model list itself they can handle the null values, but for the some of the models we have to handle the missing values, right? So and so in the third point we are talking about must be handled before the most of the algorithms. We need to handle that. But some of the algorithms, you don't need to handle that. The model itself, they can handle that whatever the missing values, right? So now you have a sort of understanding about what is missing values, why it matters for as a data scientist, why it matters for me, right? So the first one is it can be lead for the inaccurate results and its effect for your model training and the evaluation. And some of the, if you are using the whatever the fancy models, so we need to, before whatever the applying that algorithms, we need to handle that missing values, right? So now we'll see what are the different techniques we can use to handle the missing values, right? So uh, so uh, before that, this is the simple code I generated for the sample data, right? So think about you have a this is the data set, right? So you have some of the columns, age, annual income, likewise. We have a columns, right? These are, so in here, this think about you are going to uh, predict the future claims, right? So as example, think about business struggle with they have a problem regarding the claims. So with that problem, now we are going to create an analytical solution, right? So this is the one thing about you have the whatever the that particular policy hold age and annual income, whatever the vehicle vehicle age and the number of accidents, some sort of a data you have, right? So with that sometimes so when we just for your understanding this, because in here we are not talking about the target variable creation and all. So sometimes, not sometimes, the most of the time, so we are not directly getting the whatever your target variable from the business data, right? You have to logical, you have to come up with a logic how I create my target variable, right? It need to be, you can whatever you can decide, okay, this is the logic I'm using to create a target variable, but you need to validate that with the business, right? You need to get that business confirmation is the logic is okay with them as well, right? So the most of the time you need to create your target variable by yourself, right? So think about whatever using. So here I use this logic to create the target variable, right? So think about this is the data you have, right? So so before doing the pre-processing, just got some of the understanding of data. What are the data types of each variable, right? And some of the data summary of that each feature. What is their count, mean, standard deviation, right? Then you can get a sort of understanding about the distribution of your data. If it is a numerical one, then you can get sort of understanding about the distribution of the data, right? So after you did whatever the understanding of the data, you can use this uh, code line to identify the how many null values in my each feature. So here you can see in the age and the annual income column, you have 25 and the 37 uh, numbers, right? So just try to do here. I get the whatever the count, but I recommend try to get the percentages from uh, whatever your number of rows you have as a percentage. Age represent how many null values. The annual income represent how many null values, right? Now think you identified from your data set, okay, the age and the annual income, we have the null values, right? These these two columns are numerical. The age also numerical and the annual income also numerical, right? So with that understanding, okay, now you identify what are the data set you are working on. You identify in these two numerical columns, you have the null values, right? Then we'll see what are the different approaches, right? So I explain this, how you identify the from the data set itself. So here I use the pandas, right? So if you are working with the PySpark or whatever the Spark related, so you can use the different code. So in here I'm using the pandas data frame, right? So then we'll see what are the techniques, right? The simple way is the removing null values, right? So we can simply, right, using this df.drop_na, right? You can drop rows with any null value. If that particular row has any null value, so it's simply removing that particular row from the data set, right? And you can use this whole command. There's a different ways you can as you pass it as a parameter, right? So in here, the second method, if that particular row has all the values are null, then you see simply removing from the data set, right? Or else you can specify the whatever the columns. You can use one column or the two columns or three columns as a, you can pass it as a list, right? You can identify whatever the null values in that specific column, then you can remove it, right? So now this you have this the first technique you learned it. So the removing null values is the first one. So when we can use this removing nulls, right? So think about you have some of the feature, someone or feature, right? It's more not more critical for the whatever the model creation, right? It means not critical mean is not that much relation. It's not that much relationship between your target variable, right? So simply if it is that much not related to your target variable, then whatever the relationship, so you can simply remove that particular column, right? Or else you can okay, or else you can losing those rows, whatever the rows not affecting for your analysis, right? Then you can simply remove that particular rows, right? So you can apply as example, you can apply this for the not only for the rows, if that particular column is not that much has a relationship, you can simply remove that column, right? So the second technique is imputation techniques. We are talking about imputation techniques. So sometimes you can fill whatever the null values with some of the constant, right? You can fill that with the zeros or some of the string, right? If it is a categorical variable, you identify that particular category. Think about, you identify the whatever the mode of that particular category. You can simply replace with that particular mode, particular categorical value mode with the null values, right? So this is the constant value imputation, and next we are talking about statistical imputation. So if you have any numerical value, numerical column, right? So simply you can fill that with the mean, median, right? For the, or else you can go with the mode. If it is a categorical one, then you can go with the mode as well, right? So now we learn about uh, the constant value imputation and the statistical, and we are removing some of the rows, right? For the removing the some of the rows, you can use the any nulls method, or the all the values, or the specific columns you can use, right? So some of the advanced techniques, right? So in this, the forward and the backward field, right? This mostly used in the when you are working with the time series data, right? So you can use when you are dealing with the time series data, then you can use this method, this forward and the backward field, right? So what we are doing it here is the method is forward fill, right? So as example, I'll show you with this data set, right? So think about here in the annual column, if you are applying the whatever the forward fill, right? Forward fill, then this the third row, in the third row for the annual income column, you have the null value, right? If you are using the forward fill for this column to handle the missing values, right? Then this third row, that whatever the annual income value, fill with this 7,000 number, 79,000 number, right? Then if it is a backward fill, right? So here we can't apply the backward fill because the backward number is also null, right? So then I get this example, second one, right? So in here, if you are using the backward filter, uh, backward handling technique, right? Then it's filled with that 75,000 number, right? So in this backward and the backward field and the forward field method, most of the time it's applying in the time, if you're working with the time series data, right? This is the one of the technique you can use to handle the null values, right? So there's another technique. So I'm not that much recommend these techniques because I'll tell why, right? So you can use some of the models to predict the missing value. As example, so here you have a missing value, right? So using whatever the, so in here you can see this only the, and this in the second row, right? You are this actually this your third row, right? The index is 2 and your row is third row. So in here you can see your annual income, whatever that column, whatever the value is null, but others you have other, whatever the other columns you have the values, right? You can create a model using whatever the other data. You can predict your whatever the null value in your annual column, or else you can use some of the clustering techniques, right? To predict, to get, not actually, if you're using clustering, not actually predict, it's using the whatever the group by, and you can identify the missing value. But I'm just saying you can fill the null values using the regression or the whatever using the algorithms, right? So why I'm not saying this is not a good method, right? The reason is, as example, you everyone know, think about if you are using, think about you have a model, right? You are using that particular model output to another model as a feature, right? Then the first model output is a input for your second model. It's an input for your second model, right? Then what will happen is you are what everyone knows, for a model we have an error, right? There's an error term, right? But if you are using the two models, then the error can be multiplied. Then your error will be, think about the first model error is E1, the second model error is E2. Then if you are integrating two models into it, then your E1 multiplied by E2. Right? The error term is high. That's why I'm not recommending this model-based imputation, right? Because you are using the one model output for the second model input, right? So these are some of the techniques. So you can use the imputation technique, the constant value and the statistical value approaches, and you can use the forward and the backward filling methods and the model based approaches, right? So now we have a question. Okay, how you thought about the different four or five techniques for us? How we identify the, if we have such a scenario, how we identify what's the best method to fill my null values, right? So how to choose that whatever the right method? This I can't say this is exactly 100% right method, but with some of the experience and all, right? We can say the most of the time you can use, if the scenario is like this, then you can use this method, right? So actually we can't say this is the 100% right method to handle the null values, right? But this is a sort of with the experience and all. So you can use this and you can try the other methods as well, right? So if you have few nulls, it means you are representing 1%, 2% nulls in your whatever the particular column. You can use this drop rows method, the first method we talked, right? If you have a numerical data, whatever the feature is, if it is a numerical one, then you can go with that the imputation technique I talked about, statistical ones, right? You can uh, fill that with the mean, median, and the mode, right? Interpolation, right? So if it is a categorical one, you can use the mode. The simply you can use the whatever the mode, right? Or else you can come up with some of the constant value, right? If it is time series data, you can use that forward and the backward fill method, right? So if it is ML pre-processing part, I'm just not recommending this one. So you can go with some of the imputation and the indicator columns, right? So these are the things I want to cover up under the how we handle our missing values, right? So in the section, so we covered the how we handling the missing values, right? Then we'll see uh, then we'll see how to handle your outliers, right? Now you know how to, if you have any sort of a missing value in your data set, you know how to handle that. What are the different techniques you can use? If there is such a scenario, how you know how to, which method you need to use, right? So with that knowledge, we'll see what is this outlier, right? Why we need to handle that, right? What is the outlier simply means, right? So you think about, you have a color, right? You have a whatever the feature, right? There's some of the point it's significantly different from the your rest of the data, right? In here you have an example, right? This is, think about, you have the whatever the salaries of the whatever the company employs, right? So it's in here you can see the first four record. It's, yeah, if you average it, it's around 38 40,000 between that area, right? But suddenly you see a value like this much. It's compared to the whatever the four values from the rest, it's different from the rest, right? It's significantly different from the your rest of the data, right? Such a data we are saying it's an outlier for the whatever the outlier for that particular feature. What that outlier means, it's significantly different from the rest of your data, right? So there are a couple of ways we can handle the outliers, right? So I just want to introduce you the how we use the using that quartile approach, how we handle these outliers, right? So in here we are only talking about the quartile approach, right? So using the quartiles, so everyone knows this is the simple box plot, right? So in here you can see your Q1 and the Q2, it's your median, and you have the Q3, right? So with the help of this, we are creating a whatever the minimum and the maximum threshold using these Q1 and the Q3 values, right? So if that particular whatever the data point below the minimum value, we are saying it's outlier. If that particular data point is above the maximum threshold, we are saying it's the outlier. So you know how to with if you have the numerical data, you know how to calculate the Q1 first quartile and the second quartile and the third quartile. Then how we are using that values, how we identify this the minimum and the maximum threshold, right? You are saying if my particular data point is below to the minimum threshold, it's outlier, and its maximum, it's outlier, right? Then how we identify this minimum and the maximum, right? So to identify that, right? So this is so this is so I didn't explain that. So if you want to handle null values, so I told you that in these two columns, right, for the age and the annual income, right? So you have the missing values, right? Using the using the uh, using the null value handling techniques. So using the whatever the median and the most frequent one. So here I handle that null values. I'll share that notebook with you, then you can go through it. So for the outliers approach, right, you know how to calculate the Q1 and the Q1 and the Q3, right? So the difference between the Q3 and the Q1, we are saying it's an interquartile range, IQR simply, right? So with the help of IQR, how you define your lower bound and the whatever the upper bound, right? So Q1, it means the first quartile minus 1.5 multiplied by IQR. It's your lower bound, and Q3 plus 1.5 multiplied by IQR, it's your upper bound, right? If it is beyond the upper bound, so beyond the upper bound and below the lower bound, we are saying it's a outlier. It's it's the outlier, but it's not correct, right? So I'll tell you. So this is the theory, right? This is whatever the theory. Okay, from the if that particular value, if that particular data points below this lower bound and great whatever above the upper bound, we are saying it's a theoretically it's a outlier. But when you're working in the industry, right? When you're working in the industry as a data scientist, you need to have a because some of the domain they are in our this approach saying that particular data point is an outlier, but when you get the confirmation from the business, they are saying okay, this can be a uh, this can be a correct value, or this is a feasible number, right? This can be there, right? So in when you are working in the real projects, yes, this is the approach we are using to handle the outliers, right? But you need to get the business confirmation by sharing with them, okay, from the when we are doing the pre-processing, we identify these data points for this particular feature. We identify these numbers as outliers, right? From the business context, can you explain about these are the feasible numbers? So we need to remove that as an outlier, right? You need to get that confirmation, because yes, theoretically it's an outlier, but you need from the business itself, for the according to the domain, some of the domains, the number can be, it's not an outlier for them, right? So you need to get that confirmation from the business, and using that input, you need to handle your null values. Sorry, handle the outliers, right? So, so we talked about the one way of handling the outliers, right? Why we need to handle the outliers, right? So if it is, I told you that if it is minimum to that, whatever below to that minimum number, the maximum above to that maximum number, right? We can't say it's a exactly outlier. When you're working with the real data, you have to get that business confirmation, right? So with now, in this process, now the what's the importance of understanding the data points, simply whatever the different types of tables you have. Then now what's the importance of handling missing values, what are the different techniques we can use to handle the missing values. Now what is this outlier, what is this outlier actually mean, and what is the, in here I talked about one of the approach we can use to handle the outliers, right? So then with that knowledge, we go to the scaling and transformation, right? So why we need this scaling and transformation, right? So the scaling and transformation simply means, so think about, you are standardize your data, right? So it means, so we'll talk about some of the clustering problem, right? Think about, you are using k-means clustering, right? So in the k-means clustering, how it's work in the back, in the algorithm, how it's identified, we are using a distance called Euclidean distance, right? How we calculate the Euclidean distance? We are taking the whatever the different from the, think about two data points, right? Two data points, two data points, and we are getting the whatever the different of the x coordinate and the y coordinate, and we are getting the this thing, and we'll calculate the, we are getting simply getting the difference, right? Two data points, right? So think about think about uh, why we need the standardization. Think about for that calculation, for that Euclidean distance calculation, right? So you are simply, you are x coordinate minus x1 minus x2 squared plus y1 minus y2 squared, right? Think about your x coordinate, you have the some small values, right? Some of the for that x particular column, right? For that x particular value feature, you have the some of the value. The maximum value is 0 0.1, 0, sorry, a maximum value is 1, and the your minimum value is 0 0.1 for that particular x feature, right? So the y, you have high values. You have the million, 3D, and whatever. Think about, you have 10,000, 20,000 value via y coordinate, right? When you are getting the Euclidean distance in the clustering algorithm, right? So if you have some sort of a thing, because your y values are very high, but your x values, whatever the x feature is very, you have the small values, then that particular distance is bias, whatever the Euclidean distance you are calculating, bias for that particular y feature. Why? Because its values are very high, right? So because, think about how to avoid that scenario. Now, if you are calculating the Euclidean distance, it bias for your particular y variable, right? How to reduce that? We need the standardization. How we get that particular y and the X column to the same range, right? So that's why you need the standardization, right? To get that particular whatever all the features into the same stand, right? So for that you can use some of the standard scalar method, min max scalar method, or you can use some of the logarithms, right? So in here, in this data set, right, for the standardization, I use the standard scalar, right? So simply using your now, so in here we splitted our data set into the test and the control, right? So you did your whatever the transformation using the standard scalar, right? So simply you standardize your data, right? Think about you are working on the clustering algorithm. Now you don't need to worry about the bias of the data because your data is standardized, right? There's no bias for the particular feature because the ranges are similar, right? That's the need of the standardization. You need to stand before you are doing the whatever the model training, you need to standardize your data, right? So these are the different techniques. So in here in the code, I use the standard scalar. You can use the minimum and the maximum difference, and you can calculate that whatever the you can standardize your particular features, right? So now you know how to do the standardize and why it's important for when you are working with the when you're working with the pre-processing and the whatever the approaches, right? So with that knowledge, so the next thing I want to talk about is the encoding the categorical variables, right? So you have a question, then you need to think about so why we need to encode this variable? What's the reason? Right? Why can't we directly use that particular categorical feature direct it for the model training or the model development, right? The reason is the model can't work with the categorical data, right? The categories, right? We need to convert that to the numerical format, right? Because it's the model itself, the algorithm itself, it's working dealing with the numerical data, right? Because of that, for the model development purpose, the model training purpose, if we are using any machine learning model for your in that particular your solution, you need to convert that particular categorical variable into the numerical format, right? That's the need for your model training or the model development purpose. You need to convert that, right? So what are the ways, what are the different approaches you can use this categorical variable? So in here, in this the example data set, you can see your your region and the policy, whatever the type column, this is categorical features, right? So policy type, it's also a categorical feature. So if you are using that feature to your model development, you can't directly use that feature. The the standard way is you need to convert that particular categorical variable into numerical format for the training purpose, right? So what are the these are the two techniques you can use for the that conversion, the categorical to numerical conversion, right? The first one is the label encoding. Simply think about you have so you get this example, right? So in here you can see, think about in this under the region column, you only have three unique categories under this column, right? The simply in the label encoding, you are putting for the rural one and the semi-urban two and the urban three. Likewise, for that particular category, right, you are assigning a numerical number, right? This technique, whatever the label encoding, you can use if you have more number of categories under your categorical feature, right? Right. So if where you can use the label encoding, if you have more categories under your categorical categories under your categorical feature, you can use these techniques. The second one is one hot encoding, right? What is this means? How it's differ from the label encoding, right? In the label encoding, I told you that if you have a categorical variable, it's just assigning a numerical number for that particular each category. So here I told you that rural is one, the semi-urban is two, and the urban is three. But if you are using the one hot encode into here, right? So in here, for the under the region column, you have three categories, three different unique values, right? When you're using one hot encoding, what will happen is, so it will create two new columns. For the three categories, it will create two columns, right? ev- every time you need to get the, if you have n number of categories, the number of column, the new columns you are creating is n minus 1. It means for this region column we have the number of three unique categories, then 3 minus 1 is become 2. You are creating two new columns, right? So in here, so I did that the encoding part, right? Here you can see for your region column, it create according to that n minus 1 rule, right? It will create two new columns, right? To identify that particular, if that this value is 1 means for that particular row, this particular row, it's a semi-urban area, right? This column, this particular row 1 means this is a urban area, right? Then you have a two separate columns to identify if that particular row indicates the semi-urban or the urban, right? Then how you identify this rural one, right? How you tell the model, okay, this particular row belongs to rural. It means if we are both semi-urban and the urban, if you are getting zeros, it means for that particular row, you have the rural, right? That's why we are creating n minus one number of columns in the one hot encoding, right? So simply if you have a number of categories, we are creating n minus one number of new columns in the one hot encoding. How you, as example, if you have three categories in your particular feature, then you are creating two new columns. Then how I represent my third category, whatever the third feature, you, if you are getting zeros for the both these column, it represent your whatever the third category, whatever the categories not in the particular two columns, right? So these are the two techniques. Now you know why we need the encoding, because we can't directly pass the categorical features for the models. So we need to convert that to the numerical format. There are two ways to do that, right? So first one is the label encoding. The label encoding, we are simply identify whatever the categories in that unique categories in that particular feature, and we'll assign a number for that particular category, simple number, where we can use that label encoding. If you have more categories under the your categorical variable, you can simply go with your label encoding, right? So one additional point, think about, you have 30 categories under your categorical feature. Just try to, from your understanding, this is I'm saying in the industrial perspective. So from your and the business understanding, you can club some of the categories into one category. Simply you can group some of the categories, and you can reduce the number of categories under your categorical variable. It's a business code. You need to have that call, and you need to, because if you have 30 categories, right, it's a complex, no? Then you need to reduce that. The one way is reduce is you can simply uh, check with the business as well. You can see if there is any variable, you can group it, right? Then that 30 number become 2. Think about 5. then you can simply use the 1 not encoding or the label encoding, right? So then the 1 not encoding, if you have the n number of categories, then you are creating n minus number of columns for the whatever the remaining category shows the from the zeros of that particular new columns shows the remaining category, right? So now you have an understanding about the encoding, why we need the encoding, what are the techniques. With that knowledge, we'll move to the feature engineering part, right? So what is feature engineering? Why we need the feature engineering, right? So as example, so different with the domain knowledge you have, with the business understanding, right? So simply I'm saying I'll tell you how we, so some of the, when you're working with the industry, right? So when we are creating the developing the models, the one question we have is, okay, we can do you using some EDS, we can identify the important features, right, for the model, right? Before do that EDS, we are getting a business call and we'll ask from their point of view, what do you think to predict this? What can be the most important features for this, right? So then with the help of the business, you can think about, okay, these are the features can be uh, important for the final whatever your target to predict the variance of your target variable, right? So some of the features, think about for a small example, right? So think about, for a data set you have the age and the your weight, right? If you have the age and the weight, you can simply calculate the BMI value using your age and the weight, right? It's a feature engineering. Because why I'm saying it's a feature engineering, because you use the whatever the existing two columns and you create a new column with the help of that two columns, right? It's a feature engineering. You are creating a completely new column with the help of that two exist columns. And I think you know that as know this part, there's a separate thing called the dimension reduction, right? If you can use the feature engineering, then you can reduce your dimension adding. Dimension simply means the number of features you are using for the model, right? So in here, so I talked about in the previous example, I talked about the beginning, you have two features like weight and the height, right? But if you calculate the BMI using that weight and height, it will reduce to the one variable. Now you have the BMI, it represents the whatever the distribution in the uh, age and the sorry weight and the height, right? So from that calculation, it's a feature engineering. You are transforming whatever the raw data you have, right, to meaningful feature, right? After you transfer that into the meaningful feature, it will improve the model, the performance of your model, right? So that's why we need the feature engineering, right? So the some of the techniques I can tell you, so we can create some of the most of the scenarios, right? We are creating some of the lag features, right? How that, if I, as example, now the data shows for the t minus 1 point, this is this is the relationship with your target variable. But you can check for the what is the relationship for the t minus 2, what is the t minus 3, t minus 4, what's the relationship. It's a feature engineer. You are simply creating some of the lag features from the existing features, right? So in here I included some of the why we need the feature engineering, right? So if you are doing the feature engineering, it helps your algorithm to understand your data better. It means everyone knows what you are doing in the training period, right? In the training process, you identify what hidden patterns inside your data set, right? If you are if you created some of the good features, some of the powerful features using the feature engineering, right? Then whatever your model understand your whatever that pattern better compared to the if you are using whatever the existing features, right? And it will reduce your variance and the bias, right? So it will explain you the variance of your target variable here if you are using the feature engineering, right? So some of the if you have whatever the weak models using the feature engineering, if you do more if you do the feature engineering in the better way, if you can create some of the new features, will explain whatever the variance of the target variable clearly, then your weak models become to the strong models, right? So these are some of the example. As example, I'll tell you, think about you have a date column in your data set, right? You can, what are the new features? What are the, using the existing features, what are the new features you can create? So simply, if you have a date column, you can create a day, whatever the specific day. It's belong to which week of the year, and is it a weekend or a weekday, right? Or else you can create is a holiday, some sort of a features you can create what using the whatever the existing features you have, right? So you can use if there is any uh, text, then you can simply get the length of pen, then you can create a sum of the new features. Some of the ratios in the previous example, I talked about the height and the weight. Using some of the ratios of that particular columns, you can create some of the new columns. You can use some aggregations, right? So you can use the mean, count, and some of the rolling stats, rolling windows, right? So window partitions and all, you can create some of the new features, new features under the feature engineering. So why this feature engineering is important? If you can create better features using the existing features, then that particular features explain the variance of your target. Then it's easy for your models to understanding the whatever the relationship, understanding the patterns inside your data, right? So these are in here I gave you some of the examples to the feature engineering, right? And why we need this feature engineering, right? So yes, so now talked about the we talked about the handling missing values and the outliers, scaling and transformation, encoding, different encoding methods, and why we need the feature engineering, what are the techniques, what are the examples for the feature engineering. And now we have good understanding about the some of the areas in the pre-processing, right? So now we move to the data augmentation. What is this data augmentation? Why we need the data augmentation, right? What this data augmentation simply means, right? So before move to the definition, right? Think about, you guys are working on a classification model, right? So in that, I think I can use this one, right? So in here, your target variable is your claim. This is a, in that under the claim, it's a binary column, right? You are predicting the claim or not, the 0 or 1. If it is claim, you are considering at 1. If it is not, then 0. It's a binary classification problem. Then your target variable is a categorical one, right? Then you have to go up with the some of the classification model. We have different classification. We can use decision trees, random forest, boost some of the boosting algorithms, right? So think about in from the data set itself, right? I just want to explain you why we need this augmentation, right? So in here, can you see in our training data set, right? This is a data set we are using for the model training, right? So in this data set, for the one cases, it means the claim cases, we have 245, and the not claim cases 155, right? So there's a class imbalance in that data set, right? It's not actually, it's not balanced. Think about, you have a scenario like whatever the from the under the training data, right? For the 80% of your values are 1, sorry, 80% value of your values are 0, it means not claim. And 20% of, or the, think about this, this is 90%, the not claimed one is 90% and the claimed one is 10%. Then there's a bias because your data set is biased for the not claimed one. Then what will happen? Your model is biased for the not claimed scenario, right? But if you are checking your the after you train your model, right? To evaluate your model, you check that with the test data, no? Or else you can use the whatever the validation data, or the it's for the most of the time we are using for the to find out the optimal parameters, right? So if you are using your test data, right, to evaluate your model, right? So if you have such an imbalanced scenario, right, then your model can be biased for the not claimed category, right? So think about in the evaluation process, if you are using accuracy as a measurement, then it's not correct because why? The most of your scenarios are unclaimed one. Then because of that, your model can be shows as the 80%, 90% accuracy. It's not actually because of the your model is good. It actually the bias of this data, the imbalance of this target variable, right? So in this scenario, right? So if you are working with the classification or the regression problem, right? So if you have this sort of imbalanced data set, right? You need to balance that, right? So how do you balance that? Because this is the actual scenario, right? So if you are taking a period, in that period, 10% of my covered for the claimed and the remaining 90% covered for the unclaimed, not claimed, right? So then we do, this is whatever the actual data shows us, right? But for the balance scenario, to balance that particular categorical for the, if you are using that whatever that data directly to the model, then there can be a bias. To avoid that, we have to generate some of the new data points, right? So in that's what for that's why we need this data augmentation. So what is data augmentation? Simply means it's a process of creating new data, training data, or the training data, right, for your model, right, from the existing data, from the whatever the existing data you have, you are creating new data points to train your model to improve the model from performance and the robustness, right? So actually it's not your actual data, right? So you are getting generating new data from the existing data you have, right? And actually you are not collecting that whatever the data, you are simply generating new data points using the existing data, right? So why do we need the data document? So in the last example also, I told that because of this class imbalance problem, there can be bias. So because of that bias, we need to balance this scenario, right? So that we need to create some of the data generation we need to do, right? So actually why we need this data augmentation, right? So the first one is the so you can increase whatever the data size, right? So think about you have the 100 data with the data augmentation, you can increase that to the 200 data points, right? And it's reduced the overfitting. What is simply overfitting means? Overfitting means for your training data set, your model gives the high accuracy, but for the test data, it's a low accuracy, right? For that scenario, we are saying your whatever the data, it's fully fit for your the training data set. It means for the it doesn't give high accuracy for the unseen data, right? Because of this technique, we can reduce the overfitting as well, and the variance and the robustness of your models, right? So simply it will handle the previous example I talked about, the handle the class imbalance problem if you are working with the classification problem, right? So for the tabular data, right, in here we are only talking about tabular data because if we are going to the image processing, right, then there are also from the pixels and all we can do the augmentation, right? In here we are only talking about the tabular data. What are the techniques we can use for the data augmentation, right? So the one technique is we can go with the smooth, right? That is the most commonly we are using in the industry, right? If you want to generate some of the new data, right, for the under the data augmentation, and we can go with the noise ingestion methods and the bootstrapping and the resampling, right? So simply according to the sum of the distribution, right, you can use the normal distribution or whatever the according to your distribution of the data, right? You can generate some of the samples, data, new samples using the bootstrapping, right? So in here, I just want to talk about you the smart technique, right? So what these smart techniques doing is, so as an example, think about you have two data points, right? You are x14 and in this present in this slide, you can see the x14 and the x12. These are the, think about your data points, right? So you are simply generating a data point between that x14 and the x12 data point, right? That gap can be anywhere. The gap can be, you can decide whatever the gap, it can be 50-50 or the 25 to 75, right? You are simply generating a new data point between that existing two data points, right? Likewise, you can generate with whatever the same distribution, but you are generating a new data point for your data set or your training data, right? So this is the smart technique is mostly in the industry also we are using that this technique, right? So this is the way of how you generate the data. In this example, right, I used the uh, smart technique for the oversampling, that technique for the whites means the oversampling, right? We can do that the class balance in two ways, right? You can reduce this one number, it means for the claim number to 155, or else you can increase this not claimed 155 to 245, right? So that's the oversampling and the undersampling, right? So in here we'll you we use the smart technique, and using that smart technique we'll balance this class. Now if you use the whatever if you generate the new data under the data augmentation using the smart technique, what it what how its work is, if you are getting two data points, it will generate a new data point with between that particular two data points area, right? So now you balance this class. Now you have a balanced one, right? Now you can train your model. Now you use if for the training accuracy, if you get the whatever the accuracy, it's okay. Now you have, because now you have the balanced data set, right? So this is how we, if you have an imbalanced data set, using the data augmentation under the, we have the smart technique, using that, how you balance your whatever your target variable class, right? So this is the a data augmentation part, right? So in this presentation now we talked about what's the importance of the understanding the raw data, our columns and all, right? And we talked about what are the different, if you have a missing values, what's the importance of that, why we need to handle that, right? So then if you have outlier, how you identify the outlier, but you need to have that business code in the theoretical, yes, it's a outlier, but you need to get that confirmation, is that exactly outlier, right? And we'll talk about the standardization, the scaling and the transformation. And if you have a categorical variable, how you convert that to the numerical format, and under the feature engineering, different techniques, and some of the, I talked about some of these examples and why we need the feature engineering, right? And simply in the finally, we talked about the data augmentation, how you create the new data, right? So if you have a class imbalance problem, if you are working in the category classification problem, if you have the class imbalance, how you handle that, right? Using the smart techniques, right? You can search on that other two techniques as well for the bootstrapping. How you, it's simply using the whatever the distribution you want, it's simply creating the sum of the sample data set, right? You can use that whatever the data for your modeling, right? Okay, in the pre-processing and the augmentation for the, do you have any questions? If you have any question, you can put it in the chat, or else you can unmute yourself and you can ask. What is resource? Could you send the slide? Okay, sure. Can you clear out all the granularities? Okay. The first question is, what is granularity means? Okay. The granularity simply means in the business, in the industry we are talking about, okay, the granularity of that table, right? So it simply means the whatever the primary key of that table, but how you uniquely identify a record, one record, right? So as an example, right, I'll tell you using this, right? So think about, right? So think about this data set has the whatever the uh, vehicle data, right? Then simply granularity means this data set in the vehicle level, right? It means for the whatever the vehicle you have a unique number, no? It means what the number plate number, right? So that is the granularity of that table. Think about if you are dealing with the customer data, the granularity of that data set is it's in the customer level, right? So think about keys, right? Keys, they have the transaction data, right? For the transaction data, there can be, we have the date, and we have several outlets, right? And the different items we have, right? Then that particular transaction data, the granularity of that transaction table is, it's in the date, item for a specific item, and the specific item and the branch, whatever the keys branch, right? And what is the granularity of that table? It's in the date, item, branch level, right? That's a sort of the granularity. What's the how we identify the unique row, right? I think uh, you understood that, right? If you have any doubts, may send me an email or something. I'll explain it with some of the examples and all. Okay, I'll share the slide with you guys. So, okay, what resources would you recommend to deepen the understanding these topics, right? Okay, so I can share with you some of the materials, some of the reading books and all. I'll send that to the organization team, I think. Then after that, they will share with you the some of the resources. So mainly in that, so as example, so the most of them are university students, no? Right? So most of the courses, most of the degree programs, you need to do an internship, right? The best way is try to do some projects and try to add that to their CV, right? So just you can just go through some of I'll share some of the materials of the related to the data processing and the not only the data processing, the whole the process and how what are the methods we can use for evaluating the models and how we do the productionization, right? How the DevOps part coming, how the CI/CD part coming, right? So I'll share with you that. And for my advice is try to do with the knowledge. You need to have that proper understanding about what you are doing, right? So there are some of the YouTube channels you can go with. There are some of the they are doing some of the good projects, right? For the I think try to do more the projects by yourself and with the understanding, not do without the understanding. If someone asks any questions regarding your project, you need to simply you need to within two 3 seconds you need to reply, right? For that understanding you need to have without you need to do that project with the understand, right? So try to do some of the projects related to get a data set, join that with if you have several data, join with that and do some of the previous things, some of the feature engineering, right? So think about, right? So I'll share the some of the materials and the what are the things you can use. And apart from the Ds, do you need collapse only or the will use the local GPUs for modeling? Yes, you can use the local GPUs for the modeling, or else you can go with the collapse. They have some of the pro version if you are working with some of the deep learning modeling or the some of the high data volume working. You can go with some of the pro versions, right? Because I know for the free version you can't work with some of the massive data if you are working with the big data, right? Just try to learn now. You know the Python and all, right? I guess, right? You are most of them are working with the pandas data frame. Try to just check what are the big data. If you have the big data, what are the there are something called the weekend. So in here, if you are working with the pandas data frame, right? It's not parallel processing, right? It's the single node. If you are working with the pandas, right? That's why if you are using the massive data, it takes some times for the processing and all. If you are working with the Spark data frames, right? It's a parallel processing, right? It's running parallel running multiple nodes, right? Just check what is Spark, what are the Hadoop. There's Hadoop also. If you have some of the big data, what are the what are the ecosystems you can work on, right? So anything else, I'll share the materials with you guys with some of the YouTube links and some of the books, uh, online available books and all. Any other questions? Anything else do you want to highlight? Do you want to know any sort of it's Just ask, it not need to be related to the data pre-processing and augmentation. Do you have any other question? I'll answer you. Okay, I'll send you my email. I'll share that with the organizing team, then they will send it to you. Okay, sure. I'll share the resources with the organization team, then they will simply share with the group members. If there is no questions, so someone asked about what do you think about the job market related to data science field? How can we start our path? Okay, so I'm just saying for my understanding, right, from the experience and not. I'm just saying now, yes, there are different AI because of the evolution of the AI. There are some fancy things. Some are saying generative AI, agentic AI, right? Yes, but I am saying for the data scientist, right, the most important skill you need to have is the problem solving, right? Think about think about you identify a problem, right? If you can't analytically solve that problem, the approach, how I solve this problem, how I create a solution using the analytics, right? If you can't do that, then where you need to use that part, but agentic AI or the Gen AI or the whatever the analytical machine learning models, right? The most important skill for the job or the future you need to have is the problem solving. If you see the problem, okay, you identify, you know the problem, how you create a particular solution for that problem. I think it's a must. You need to think for that. To improve that particular skill, you can use some of the techniques like W5H method, or can use the fishbone structure. That's the how you solve that particular problem, right? So diagram, you can use some of the diagrams as well, right? So the job market is, I think, in Sri Lanka, I'm just saying, there's no compared to the other countries, right? So there's no much job market here in Sri Lanka, but for the countries like USA, Dubai, UK, there are more opportunities you have, right? Any for the future, I think for the next 5 years, right? The data scientist, AI engineer, big data engineer, right? These are the most valuable and the whatever the high payment jobs, right? So don't worry about the job market, right? Anyway, you have a job because of the evaluation and of the AI and all. Anyway, you have a job, right? So you need to think about how I be changed now. And now you know there are several courses, there are degrees, there are several degree programs, right? To learn about the data science and all. But think about how you become unique from the whatever the others in the market, right? The one way is the page where I talked about. You need to do more project. The first step is to find out an internship. You need to do the more project with the understanding. It's a must, right? Then the next question he asked about the how can we start our path, right? Just start with this. Get the simple data set, right? do some EDAs. What are the inputs? What is the input? What is the output? What are the conclusions you can come up with? And do simple EDAs. Try to create some of the graphs and to see some what's the hidden patterns behind the data set, right? Just to get sort of understand. Then after the EDA, just do some whatever the model building, right? And whatever the model evaluation, what are the techniques, what are the models, learn about the machine learning. First step is learn about the machine learning, then move to the deep learning, right? What are the evaluation metrics we can use according to the model? If you have a regression model, what are the evaluation metrics we have? If it is a classification model, what are the evaluation metrics? If it is a clustering one, what are the methods you can use? Right? Learn about those things and how to evaluate. Then try to, now you have a fancy model, then try to build up some interfaces with that, with the help of your model, right? So it can be a Streamlit application, or else you can create some of the using React or whatever the application, right? Try to create application, right? It's a simple project, right? Do that work, then I think it's, if you can do that, it's you are 100% ready for the first whatever the internship. Then we are working in the industry, then you can learn the some of the, you can work with, now you work with the whatever the simple data, but if you are attend to the whatever the industry, you can work with the actual data, you can face whatever the actual problems, then you are gaining a knowledge from that, right? Just start with the simple data set with the EDS, and the step by step you learn, right? So, is the AWS solution architect certification for data science undergraduate hard to for the AWS solution architect certificates? Okay, you need to. I think I can share with you some. If it is the AWS solution architect certification, I can share with you some of the materials as well. I'll share with you. For the AWS, I think you need to spend, 3 or 4 months with some of the hands-on asset, because you need to do more hands-on with the AWS, right? So I'll share with you some of the materials here to the that particular certification as well. I'll share the presentation with the organizing committee, then they will provide you. Okay. Do we have more statistics to the justice? I'm not clear about the question. Do we have more statistics interest to the choose TS and maths for AI? Should we? You are just asking for the. Do we need the statistics and mathematics for the? I think you need both the statistical knowledge. You need to have more about the hypothesis testing and some of the descent control splits, right? So that knowledge you need to have, right? Basically, the hypothesis testing and all, it's a must, right? For the mathematical algebra, linear algebra, if you have that knowledge, it's good. If you are working with some of the optimization problem, if you have that knowledge, then it's good for you, right? I'll share that the LinkedIn and the email details with them, then they will share with you. What is the skill that mainly need for the data engineers? Data engineers. So they need to know that whatever the ETL process, right? For the, I think the you need to have a sort of understanding about the CI/CD pipeline creation, right? Because in that we are mainly working with the data ingestion, and under the DE we are working with whatever the raw data we need to get that to the primary layer. To primary layer means for the DS data scientist usage, right? So in that area, I think you need to know about how to convert that whatever the raw data into the intermediate, and intermediate to the staging to how we get that data to the primary, right? And you need to have a good understanding about the Kedro pipeline, how you do the Kedro coding, how we work with the nodes, right? And sort of understanding of that the Kedro pipeline. You need to have that knowledge, and the ETL process, how you get that data from the Azure, the AWS data lake, how you get that data to the tabular format and all. You need to have that understanding. Okay, I'll share the presentation and my email and the LinkedIn and the needed resources with you guys. Right? You can follow up. If you have any question, you can reach out to me in LinkedIn or using my email. So if there is no any other question, we can wind up the session. Anyone from the organization, do you want to discuss anything? Hello.
Thank you very much, Mr. Indira Veerasinghe, for that engaging presentation. The practical insight you shared will surely add a significant value to our data science journeys. On behalf of organizing committee, I would like to sincerely thank all participants for your active engagement and thoughtful questions. A special note of appreciation once again, Mr. Indira Veerasinghe, for sharing his valuable time and expertise with us today. As a token of our sincere appreciation, the IEEE Computer Society Student Branch Chapter of SLTC is pleased to present a token of appreciation to Mr. Indira Veerasinghe in recognition of his valuable contribution, time, and commitment to empowering our student community through knowledge sharing. Although this session is conducted virtually, this token symbolizes our gratitude and respect, and it will be officially conveyed to you on behalf of organizing committee. Thank you once again for being a part of Codemania version 6.0. As we come to the end of this impactful session, it is time to express our sincere appreciation to everyone who contributed to its success. To formally deliver the vote of thanks, I would like to invite the Secretary of Codemania version 6.0, Nipuni Senaratna, to take the virtual stage.
Thank you, Navi. Good evening, everyone. I am honored and delighted to deliver this vote of thanks on behalf of the IEEE Computer Society Student Branch Chapter of SLTC. Today's session, Workshop 1, Data Preprocessing and Augmentation, mark an important milestone in the Codemania version 6 journey. This workshop laid a strong foundation by equipping participation with essential knowledge on preparing, refining, and enhancing data skills that are fundamental to building effective and reliable data-driven solutions. Our sincere gratitude goes to our guest speaker, Mr. Indira Veerasinghe, data scientist at John Keel's Octave. Thank you for sharing your expertise, industry experience, and valuable guidance with our participants. We are deeply grateful to have with us Dr. Sanika Vijayasekara, Dean of the Faculty of Computing and IT, Dr. Lasithya Saketu, Branch Counselor and Senior Academic Treasurer of the IEEE Student Branch of SLTC, and Mrs. Varonika Hippola, Branch Academic Advisor of the IEEE Student Branch of SLTC, and Engineer Chamira De Silva, Head of the Department of the Data Science. Your present, continued guidance, and unwavering support play a crucial role in the success of initiative like Codemania version 6. I would like to extend my appreciation to our Mr. Dhananjay Atigamman and the advisory panel, Mr. Nitin Fernando and the roundtable members, and IEEE Computer Society Student Branch Chapter of SLTC, including Ms. Vimashana Kitmini and all executive committee members. Your leadership, direction, and commitment were instrumental in making workshop a success. A special thank you goes to the organizing committee and the media unit. Your dedication, coordination, and behind the scenes effect ensure the smooth execution of this session. To all our participants, thank you for your active participation and eagerness to learn. Finally, thank you to everyone who joined us today and contributed the success of this workshop. We look forward to your continued participation in the upcoming workshop, the virtual hackathon, and the grand finale of the Codemania version 6. Thank you and have a wonderful day.
Thank you, Nipuni. To all our participants, thank you for being with us today. We hope you leave with a strong understanding of how effective data preprocessing and augmentation directly influence model performance and decision-making quality. This concludes Workshop 1, Data Preprocessing and Augmentation under Codemania version 6.0. We look forward to your participation in our upcoming sessions. So with that, signing off as your moderator, I'm Navin Karyavasam from the SLTC Media Unit. Have a wonderful evening and stay safe. Good night.